Every AI-generated image starts as pure static, and what happens next is genuinely strange. Take a photo of a cat. Now slowly bury it under random noise, layer by layer, until the cat is completely gone and all you have left is static. That destruction process is actually the first half of how diffusion models learn. During training, the model watches thousands of images get destroyed this way, one small noise step at a time. At each step, it tries to answer one question. Given this noisy image, what noise was just added? If the model can learn to spot the noise that was added, it can also learn to subtract it. That is the whole trick. Run the destruction process in reverse, and you get something that looks like a real image. The math behind each step uses something called a Gaussian distribution, which is just a fancy name for the bell curve shape of truly random noise. Each forward step adds a small, precisely measured sprinkle of that randomness. The model that does the actual denoising is usually a type of neural network called a U-net. It looks at the noisy image at a given step, predicts the noise component, and hands back a slightly cleaner version. To generate a brand new image, you start with a grid of completely random pixel values, pure static, and run the trained model on it, over and over, maybe 1,000 times. Each pass peels away a little noise. After enough steps, structure starts to emerge, edges appear, then shapes, then textures. It is not magic. It is the model applying what it learned about how real images are structured, one small correction at a time. Most modern systems, like Stable Diffusion, do not actually work directly on pixels. They work in a compressed version of the image called latent space. Think of it as a smaller, more efficient map that still captures the important information. Working in latent space means the model can denoise a much smaller grid of numbers instead of millions of raw pixels, which makes the whole process faster without losing much quality. When you type a text prompt, that text gets converted into a list of numbers by a separate model, usually something like clip. Those numbers are fed into the denoising network at every step, nudging the image toward your description. This nudging is called conditioning. The noise removal is not random, it is guided. The model is always asking, does this image so far match the prompt? And it steers accordingly. There is a setting called guidance scale that controls how strictly the model follows your prompt. Turn it up high, and the image matches your words closely, but can look a bit overcooked. Turn it low, and the model has more freedom, sometimes too much. The number of denoising steps is also a trade-off. More steps generally means a cleaner, more detailed image, but it takes longer. Researchers have found ways to get decent results in as few as 4 or 8 steps, though the math gets more complicated. So the next time you type a prompt and an image appears, what actually happened is 1,000 small noise subtractions, guided by a model that spent weeks studying how images are built, working backward from chaos towards something coherent. If you want to go deeper, the original paper that started all of this is called Denoising Diffusion Probabilistic Models. It is surprisingly readable for an academic paper and free online.